Okay, let's unpack this. We're doing a deep dive into what might be one of the biggest shifts in automation this decade. I'm talking about the physical intelligence revolution. And our mission today is to really understand how humanoid robots are taking on, well, the most demanding factories on Earth's semiconductor cleanrooms. Fabs.
Right. And the real milestone we're zeroing in on here is that December 2025 agreement, the one between ST Microelectronics and Oversonic, the Italian company. It's so critical because this is the moment humanoids move out of the lab, out of the sort of experimental pilots, and onto the actual production floor.
So we're way beyond just software here. This isn't just about a digital twin anymore. When we say physical intelligence, PI, what are we actually talking about?
PI is, well, it's what happens when you get to embodied AI.
Yeah.
This deep fusion of sensing, action, and cognition, all happening inside the robot's physical body. We're moving away from what we'd call hard automation, rigid, pre-programmed stuff, to something much more fluid, flexible cognitive automation.
And what's wild is that this PI explosion, it really just kicked off around 2022. It's the large models, the foundation models, that let them learn by watching. Imitation learning.
Exactly. Which brings us to the clean room.
Here's where it gets really interesting. I mean, fabs are the ultimate test. These places are engineered to meet ISO 1, maybe ISO 3 standards. For you listening, that means, what, fewer than 10 particles per cubic meter? Particles you can't even see.
It's basically zero margin for error.
So how do you even put a complex moving machine like Roby in there without it just becoming a giant contamination bomb?
The engineering challenges are immense. You can't use normal parts. Everything has to be completely sealed joints, special Teflon coatings.
Yeah.
You have to avoid any kind of friction that could shed particles or even create tiny gas clouds.
Wait, hold on a sec for our listener. What is outgassing? Is the robot sort of slowly leaking invisible fumes?
Effectively, yes. That's a good way to put it. It's when plastics or lubricants release these tiny amounts of gaseous chemicals. In a clean room, those can land on a lens for a lithography machine and just ruin it. So the robot's own materials have to be chemically stable.
And the movement itself is a problem, right? The laminar airflow systems.
It's a constant, gentle sheet of air pushing particles down. So the robot has to adjust its own arm movements in real time so it doesn't create turbulence, little eddies of air that could stir contaminants back up.
That's incredible. And then there's the precision. I mean, in a car factory, you're fine with a tolerance of, what, plus or minus 5 millimeters.
Yeah, for a car door, that's perfectly fine. But here, you need sub-micrometer precision to place a chip. We're talking about hitting a target smaller than a bacterium, over and over again.
And on top of all that, you have ESD protection.
Yeah.
One little static shock from the robot's finger could fry millions of dollars worth of nanoscale transistors.
Right. So if we connect all this to the bigger picture, the technical hurdles are massive. So why now? Why are companies finally committing to this? Is it just that the tech is finally good enough, or are the economics just forcing their hand?
It's both, but I think the economics are what's really breaking the dam. The sources we're looking at show the bill of materials cost for one of these humanoids is set to drop by 40%. Think about that. From around $150,000 in 2023 down to maybe $32,000 in 2025.
That 40% number, though, it sounds a bit like VC optimism. What's the fundamental driver behind a price drop that steep in just 2 years?
It's economies of scale, really, and standardization. The actuators, the sensors, they're moving from custom lab parts to mass-produced modules. And when that happens, the cost comparison to human labor becomes, well, impossible to ignore. A robot running at $2 to $10 an hour versus what's the average U.S. manufacturing wage? $34.
Yeah, and that really highlights the clean room tax, as some call it. You're paying highly skilled people to basically be human statues, trying not to shed skin cells. That cost difference is why the ROI, the payback period, has shrunk from over 5 years to, well, now it can be as short as 18 months.
So what does this all mean then? The goal isn't just to replace a person. It's something bigger, this cognitive integration.
Exactly. It's about that 24/7 reliability. But also using the robot to constantly sense the environment and optimize the whole process.
So it's not just following a path, it's deciding on the best path in real time.
Right. It's the autonomous thinking factory. The projections say that by 2030, humanoids could be doing something like 30% of the repetitive tasks in these fabs.
And they're acting as mobile sensor platforms, making these tiny micrometer adjustments based on what the large models are analyzing. The ability to physically touch and reshape the world with that level of cognitive awareness. That's the new frontier.
Which leaves you with a final thought to chew on. As this physical intelligence masters the most complex factories on Earth, what's next? What non-manufacturing sector, healthcare, agriculture, maybe even space exploration, is going to be the next clean room gauntlet that drives this technology forward?